All right, hello and how are you? We are working on lesson 2.3 today, exponents and multiplication, and this is your Mrs. Smith, your math teacher, coming at you. Today, your target statement is I can multiply powers with the same base. We're going to do a little exploration first. And so we have 2 to the third power. 2 to the third power times 2 to the second power. So what does the 2 to the third power mean? 2 to the third power means 2 times 2 times 2, and hopefully you agree with that. Times, and then the next one is 2 to the second power, and that means 2 times 2. So when we were doing these in the past, or when you've been doing them in the past, maybe a previous school year or something along those lines, you know to keep the base the same, and then you add 1, 2, 3, 4, 5 2's, so you have 2 to the fifth power, right? Okay, now let's look at the next one. You've got 3 squared times 3 to the fifth. So 3 squared means 3 times 3 times by 3 to the fifth. So 3 times 3 times 3 times 3 times 3. And so keep the base the same, which is 3. And there are 1, 2, 3, 4, 5, 6, 7 3's. So your answer would be 3 to the 7th power. Now my question to you is, what do you notice by looking at the original and looking at the answer? Looking at the original problem and looking at the answer. Do you notice any similarities? Do you see any patterns or some kind of rules that sort of develop? I gave you some time to think. What do you think? Did you notice that here it was 2 and the base here was also 2? So hopefully you noticed that the base stays the same. And then, did you notice anything else? Did you notice that if you add 3 plus 2, your exponents, you get 5? Or if you added 5 plus 2, you got the 7 right here? Hopefully you did, because that's kind of the rule. The base stays the same and you add the exponents together. So base stays the same and you add the exponents together. So let me kind of point out what we're doing. So if I highlight, here's the base, it's 2, here's the base is 2, and your answer, the base is 2. Here the base was 3, here the base was 3, excuse me, excuse me, and your answer, the base was 3. Let me pick up another color. Oh, before I pick up another color, so the base stayed the same. All right, so now let me pick up another color, and notice if I add the 3 plus the 2, you come up with 5. If you added the 2 plus the 5, you came up with 7. And so the other part is you add the exponents together. So that's the rules. And you can see them written right down there if you happen to look at that. And the rules say, 1, keep the base the same, and 2, add the exponents together. So we could do it both ways. We could do it long ways as well as the pattern way that we noticed. So how about if we have 5 to the third power times 5 to the second power? So again, I know that that's 5 times 5 times 5. And I know that this is 5 times 5, which is 5 to the second power. So I have the same base, 1, 2, 3, 4, 5. I have the base of 5. And then I have 5 of those 5's, so my exponent is 5 as well. So 3 plus 2, if I add them together, well, that didn't really look like an add, I guess. Let me get rid of that and do this. And that equals 5. And then if I pick up the yellow, my base stays the same, 5, 5, and 5. Okay, so I think you can kind of see that rule works. So we're just going to use the shortcut and do 7 to the 4th times 7 to the second. So keep the base the same, which is your 7 and your 7. So your base would be 7. And then you're going to add your 4 plus your 2, and 4 plus 2 is 6. So it'd be 7 to the 6th power. Okay, here we go. One more. Number 3, I'm going to squeeze in over here. How about 12 to the 7th times 12 to the 8th? 12 to the 7th times 12 to the 8th. So keep your base the same, which would be 12. You add your exponents together. So 7 plus 8 would be 15. So 12 to the 15th power. Okay, well, what if your base wasn't a nice whole number? Like we had 5, we had 7, and we had 12. What if we had 3.4 to the 3rd power times 3.4 to the 10th power? Notice I put parentheses around this to notice that the 3.4 goes together and the 3.4 over here goes together, and not 4 to the 10th power and 4 to the 3rd power. So they put parentheses around it just to lump them together. So what's your base? Well, your base is this 3.4 and this 3.4. So my base here is going to be 3.4. Doesn't really change much. I would still put parentheses around it though. And then you're going to add your exponents. And 10 plus 3 is 13. So decimals don't matter. All right, do not matter. So how about variables? X to the 3rd times x to the 8th. X to the 3rd times x to the 8th. Keep your base the same, which would be x. And then add the exponents. 8 plus 3 is 11. So it would be 8 to the 11th power. Doesn't change anything. It certainly doesn't change anything. So how about number 6? Negative y to the 3rd times negative y to the 5th equals, and again, they put the parentheses around there to signify that the negative goes with the y. So your answer is going to be negative y, and then if you add 5 plus 3 to the 8th power. Okay? All right, so let's take it up a notch. What would happen if I had 4 to the 3rd times 4 to the 2nd times 4 to the 6th? Uh-oh, I have 3 of them. Still doesn't change much. This is our base. They're all the same, 4, 4, and 4. So my base would be 4. And then my exponent, what I'm going to do now is I'm just going to add 3 numbers. 3 plus 2 plus 5. So 3 plus 2 plus, not 5, 6. Well, 3 plus 2 is 5, and 5 plus 6 is 11. So it'd be 4 to the 11th power. Not too bad. So you try this one, number 8. How about 5 to the 2nd times 5 to the 8th times 5 to the 4th? You can definitely stop the video and figure it out. Hopefully you said your base is 5. And if you added the 2, the 8, and the 4, 10, and 4 is 5 to the 14th power. Is that what you got? Hopefully so. All right, well, what happens with this? 3 to the 3rd times 3 times 3 to the 5th. Okay, I got the base. They're all 3s, so I've got that. What about this exponent here? There's nothing here. Do you know what I can put in there if there's nothing there? Hopefully you're telling me, yeah, Mrs. Smith, you put in a 1, because that's exactly right. You put in a 1. I call it my ghostly Gladys 1. I've always named my ghost Gladys that I think lives in my classroom. So that's in honor of her. So now you're going to add them. 3 plus 1 is 4, and 4 plus 5 is 9. So it'd be 3 to the 9th power. 3 to the 9th power. All right, how about number 10? 17 to the 2nd times 17 to the 3rd times 17. Okay, there's nothing there, so what am I going to put in? Oh yeah, my ghostly Gladys 1. So my base is 17, and if I add the exponents, I have 2 plus 3 plus 1. So 2 plus 3 is 5, plus 1 is, hopefully you said 6. 17 to the 6th power. All right, what about something like this? What about x to the 6th times x times x? So now you have 2 without variables, so all I do is throw in a 1. So you should have come up with x to the 6 plus 1, which would be 8, x to the 8th. All right, so are you ready? Let's take it up another notch. How about this, number 12? Number 12, xy squared times x to the 3rd times y to the 7th. Uh-oh. Hopefully you notice that there's 2 bases there. So we need to do 2 bases. I have an x and an x, so that's going to be the first part of it, x. I'll highlight it here. And then if I count up my exponents, there's nothing on this x, but I could put a 1. So I have a 1 and I have a 3. I'm going to circle those, 1 and 3. So 1 and 3 is 4. Okay. And then you have these y's. So let me pick up another highlighting color, maybe a blue. And I've got a y and a y. So now you're going to have a y, and then you're going to add the exponents here. Maybe I'll put a box around it this time. You have 2 and you have 7. And 2 plus 7 is, hopefully you said, 9. And notice I smushed them together because that's how we write it in algebra, all smushed together. All right, let's try one more like that, number 14. Number 14. So x to the 5th, y to the 3rd, times x, y, times y to the 6th. X to the 5th, y to the 3rd, times x, y, times y to the 6th. So again, let's pick up our highlighter. Let's find our x's. So I have an x to the 5th. I have an x. So I have x, and of course if there's nothing there, I can put in a 1. So 5 plus 1 is 6. And then pick up your y's. I'll put those in blue. So I have a y to the 3rd, a y, and a y to the 6th. So if I pick up my y's and I add my exponents, it looks like I got to throw in another 1 there. And let me just put boxes around that. So I have a 3, I have a 1, and I have a 6. So altogether that is 10. X to the 6th, y to the 10th. All right, last one. I'm going to throw you another little curve, number 15, and I'm not going to answer it. I'm going to see what you can come up with, and we'll talk more about it tomorrow. So 3 to the m times 3 to the n. Ooh, that's interesting. 3 to the m times 3 to the n. So think about your bases. You might be able to do that, no problem. Looks like you've got a 3. But what am I going to do with this m and this n? What do you think? Stay tuned. We'll talk more about it tomorrow. All right. Have a good one.